right, as we're allowing those of you to come in and join us. What's going on, guys? Get ready for the part 2 tutorial of Unity. New face with us. For those of you that don't know, I'm Psychonius. We got
Tubsy.
New to this particular branch of this channel. We had Darvis with us last week. I think it's going to be whoever can fill in and kind of learn. You did watch last week when we were on and we were doing our thing.
Yep.
What did you think so far of what we've done?
I know nothing about this kind of stuff, so it's very intriguing to me. I was always curious. Like when I first got into high school, I wanted to do animation. I was in animation. I thought that was very interesting.
Yeah, weren't you in that 3ds Max class? Yeah.
Yep. And inevitably switched my schedule and stopped taking any kind of course familiar with coding, animating, anything like that.
You guys are unbelievable.
Yes, Green Bean, I got you. But yeah, I'm very curious, very interested. I think it's very cool, and surprisingly simple from what I caught from what you were telling Darvis. It's a little overwhelming looking at everything here.
Yeah.
But once you know what everything does, like even something like OBS was, because obviously I know a lot about streaming, was very intimidating at first, and now I look at this and it's how I felt when I first looked at OBS. I'm like, what the hell is this?
Yep.
What the hell is a bit rate? What should my resolution be? I don't know. So now I'm curious. So.
Yeah. Loops and databases, that's coding. Yeah, it can be. It's part of it. The monitor, huge monitor, huge. So what we did last week was we were able to get the platform and the ball. We did literally one line of code. When we hit play, we're able to let the ball just roll, and it rolls off.
That is floating.
It is floating. Yeah, it does not actually physically roll. It will give the illusion of rolling because of like the sphere ball, and there's nothing on the ball, so we can kind of just say, yeah, it's rolling, and people will believe us. But that's the game we're playing.
Mm-hmm.
For sure. So we're going to do a couple things today, depending on how long this is going to take us. I want to reorient the camera. Okay, people didn't even see all that. That's on me. So let's actually show the group what we were able to see. So we're going to get the ball rolling again one more time. Yes, it's just floating. That's what we were able to do. We had one script. Most of this was done for us. Sorry, we did 2 lines. I forgot about that one, and then we did this one. This one controls our speed. This one literally just tells the ball to roll, and that's what we did. Okay, so we're going to do a little bit more control this time, and we're going to orient the ball. So I'm going to go back into scene view. We're going to kind of go back and forth between scene and game view, and I prefer to kind of control my camera with scene view because right now, obviously, the game view is kind of just like, it's basically the 2D perspective, right? So we're actually looking into the positive Z direction. If you look into the screen, coming out is like the negative Z direction. And then other than that, it's like how you would typically think of your XY plane, right? Positive X, positive Y, negative Y. But that's not what we're aiming for. We're not going to get much Y movement so far. So we're going to go ahead and mess with just the X and Z. So what I'm going to do is kind of manipulate this camera to how I like it. And you can do that by just, I have the Q button that allows us to do the view tool. I can just click and drag. If I hold Alt, that allows me to click and rotate. So just a combination of those 2 things to kind of get to where I want to be. And you can help me out. What do you think about that one?
It's a good angle.
That is a good angle?
Big angle guy, yep.
So what we do with that is, now that we have this kind of in place, thanks, Mitch. It's actually really easy now to just go ahead, and the camera is what we're going to change. I'm going to right-click on the camera, and I'm going to simply align with view. And then if you look down in the main camera, you can actually see it aligned exactly with where the camera is in the scene.
Cool.
And that's preferably how I like to mess with when it comes to this particular camera angle, is get it to how it's a lot easier to control like this than it is to kind of figure out with these numbers, right? Just kind of get a good feel to how it looks. Your brain hurts? All we're doing is rotating a camera.
So as you rotate it, obviously those numbers are going to change up there, right?
Yes. Well, if I rotate it right now, these won't until I say go ahead and align with view
lock
again.
It. Yeah.
So right now I can go ahead and re-rotate this, and this doesn't matter, right?
But as soon as you lock it in there.
Control wagon, sorry. But yeah, but as soon as I go to lock it in, now I kind of want to get back to this. But what I can actually do is pick the camera. Now that I have the camera how I want it, I can actually say line view was selected, and it actually moves my scene camera back to where the game camera is. So there's the game camera, there's the scene camera. If I hit play, while true, speed plus equals 1. That would be hell. That would be hell. So yeah, right now the ball goes off to infinity, but the camera stays still. That's not what we want. So we're going to do a camera follow first. And that way, maybe we can, Josh, increase the speed over time. That might be a way to make it a little bit more difficult. The game, not the game development part. But to make a script, we did this last time. I'm in my scripts folder. Just for organization's sake, please make sure you stay organized. Right-click, and we're going to create a simple script. And we're going to call this camera follow. If you recall the naming convention from last week, thanks, Green Bean. We have started with a capital letter. Make sure it is one word, and I like to do the capital letter on every single word that follows. So camera follow has a capital C, capital F.
The Tubsy,
right? That's not quite camel case. Camel case starts with a lowercase letter. I think that's just capital case. Or something like that. But so it automatically opened up Visual Studio, but it didn't open up our script. So I'm going to go ahead and just double click on camera follow again. There we go, camera follow. So again, when you make them in Unity, it automatically kind of populates it with these properties. So what is this script going to do for us? It's going to look at a target, and this target is going to be the ball, and it's going to say, I want you to stay that same distance away from the ball that you always are from the beginning as the ball moves.
Okay.
And that's kind of what we're going for here. So we need a target. We are going to create the target. When it comes to it being available everywhere, we used to use public. That was a nice way to do things for player, okay? But I'm going to do something different. I'm going to make it a private variable. This is a game object. A game object is just anything that's in the game, and we're going to call it target is the variable. Okay. Now if I do this, I'm going to go ahead and save it. This is going to be a reference, and I attach camera follow to the main camera because that's the camera. Right? We can see the camera follow, but I don't see my variable yet, and that's because it's private. And that kind of helps us keep. Oops, just punched it. Keep the variables very consistent to where like only the camera can actually affect the target variable. We don't want player to affect the target variable. That doesn't make any sense. So we're trying to make sure that things stay relatively, what would that be called, modular. And but we still want to be able to attach the player to this target. So to do that, we're going to include this kind of modifier. It's going to be called serialize field. Serialize field. Okay. And this is just something that C# allows us to do. It keeps the object private, which means the other scripts can't touch it, but now Unity sees it. So it's kind of an in-between. The other scripts won't be able to touch target, but now Unity can see it. And now we can say, my target's going to be the player. We're following the player. Boom.
Nice.
Okay. So there we go. We have our target reference. Now, nothing's going to happen because we just said, hey, go ahead and look at this target. So we don't expect anything to change, and sure enough, nothing does change, right? So we do have to tell it what to do with this target. If we recall, start happens once at the beginning of the game, right before the first frame. Update's going to happen once every frame, and what are typical frame rates? About 60 frames a second. No. So this will actually go and run about 60 frames a second.
Unless you're playing Starfield on current gen consoles, then it's 30 frames per second.
I mean, it kind of has to be. Jesus. That game looks gorgeous. So we are going to get a reference to this target. And this target's going to have some properties, including its position. Okay. So we are going to say, I want to know what the position of the target is. And we can do this by calling it a vector3. And again, a vector3 is just simply a position, an X, Y, and Z position. So we'll call it target position. And that'll be the target's transform dot position. And I like how the autocomplete just kind of does this for us. It kind of knows. It's actually very smart. So we just have a reference to this target position. That's kind of nice. And again, that's just the X, Y, and Z component of the target. But we want to know the actual starting distance from the camera to this target position, and we want to maintain that. So to do that, we need another kind of vector 3 that tells us that difference, that offset, and we're going to create that up here. Private vector 3 offset. Okay. This is just a variable that's going to hold that information. Right now it doesn't hold anything. Right now it's null. So we do have to set this, and we're going to set that at the start. So we have an offset at the beginning of the game. We want to know what that offset is. Luckily for us, Unity has a very good way of doing the math for us. The offset is going to be equal to the camera's current position, subtracting the target's position, target.transform.position. And that's just the difference. And if I don't know if this could be a little bit math heavy for you guys, but like if we did on an XY plane and we wanted to know the distance between 2 points on an XY plane, this is basically how we would do it. So that knows how to subtract the X's, subtract the Y's, subtract the Z's, and we're going to keep that information in the offset. So you can just think of right now the offset is the distance between position and target. Our camera and the target, but also there's some information about the directionality as well. So you know how we're kind of above and behind? Mm-hmm. That information is also in there.
Nice.
So that's very, very neat. Okay, so we only have to do that once, okay, and then we're going to kind of keep track of that offset and make sure that every frame we're going to move this position based on the target plus the offset. Okay. So that's what we're going to do. And there's a very nice function we can use for this. We have a nice vector3.lerp function. Go ahead and get the jokes out now.
Lerp, huh?
Lerp. It's short for linear interpolation. Yeah, big words. Just means we have 2 points that we're trying to deal with, and we want things to be smooth. This is a smoothing function.
Lerping.
Yes, lerping. Otherwise, it'll just be boop, doop, 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 and choppy, and we want to control the smoothness of this, okay? And that's what this, if you look at the vector A, vector B, float, this is our starting position, this is where we want to be, and this is kind of how quickly we want to get there. So our smoothness factor. So what is our starting position? Well, our starting position is where the camera currently is, not target, it's just be transform.position. Okay, that's where the camera currently is. We want it to be where the target is, in this case, target position plus...
So it's giving you the whole formula right here,
yes.
Basically. Okay.
Yes. So where do we want to be? We want to be where the target is plus the offset, right? So where our ball is now on this next frame, but go ahead and add the offset so we're back and behind the ball. So if the target had moved 20 feet in the X direction, we want to be kind of where he is, but plus the offset, so we still have the over-the-shoulder look. Okay.
Gotcha.
And how quick?
More like over the boulder.
Over the boulder.
Yeah.
How quickly do we want to get there? Well, this is just going to be some number between 0 and 1, and this is something you can play with. I'm going to go ahead and put 0.3f. We're going to go ahead and... What's up, Miss Tubbsy? Math and words and targets and all that stuff on pizza, anyone? Yeah, let's get some pizza.
Sounds bomb.
All right, so what have we done so far? We got the offset. This is one of the more interesting kind of classes that we like to write. But we have our offset, which is going to be just that distance. We have the ball that we're trying to follow, and then this is going to be a actual... it just does a lot of math for us, so we don't have to kind of do it ourselves. But we do want to make sure that the transform.position equals the result of that math. So this is going to figure out what would be the best way to kind of move it based on this update in this way. So there we go. Let's do it right.
So what's the not purpose? Why is like you're putting some shit down? Oh, some stuff down here. You're putting some stuff right here and some stuff up here. What's the difference of breaking it up like that?
Gotcha. So up here, these are variables that we create that are just available to us. The target, which should be available everywhere in this class.
Okay.
All right, because we're going to reference it here. We're going to reference it here.
Okay.
And then eventually we reference it in Unity. So we set the ball equal to the target. So the ball is the target.
Right.
This offset is available everywhere as well. So we have that here and we have it here. Okay. So these are things that we want to create so that they are available in any function that we write, and that's what these are. These are functions.
Got you. Below. So
Yeah.
this is the start of a function, and then this is the start of another one?
Yes.
Okay.
Yes. This function happens to be called start,
Yep.
which Unity recognizes as running once before the first frame.
First frame. So once you start it, then triggers
Then we're going to
in.
go ahead and set the offset to the math.
Right.
And so we have access to that.
Cool.
Okay. And
All right.
what that does
That explains
is
things.
now what we can, now what we can do is in Unity, if we decided to, oh, you know what, my camera angle just isn't that right.
Yeah.
We can go ahead and adjust the camera angle and reset it, and the code knows. The code knows that it's just based on wherever it is to start.
Right. Okay.
And then the update again runs once every frame. And what are we doing every frame? Well, just go ahead and get a temporary variable called target position. I could honestly just kind of replace this into here if I wanted to.
Mm-hmm.
But I like to do a temporary variable there. And we're going to do some math based on how much time has passed, where the ball is, figure out where the camera's new position is supposed to be with some smoothing, and go ahead and set that new position. And that's going to happen every frame. So this happens 60 times a second.
Yeah.
So we're going to go ahead and save that, and hopefully this should work. Oop, there we go. Going to go hit the play, and we should get some camera follow.
Yep.
There we go. It's a little choppy, okay? And again, you can mess with that smoothing factor if we wanted to. I do believe we can also include something called time.delta time, because every frame is not going to be the same amount of time in distance. It's just depending on the processing power of your computer, things like that. So this says, you know what, take an amount of information, how much time has actually passed. Right? Right, Josh? That wasn't fun. Just kidding. All right, let's go ahead and add some time.delta time, and let's see if that helps smooth what we got here. Nope, it's a little too slow.
It looks smoother.
It's smoother, but it's slow. So we do want to probably
Speed it up.
Speed this up. Let's go ahead and say, and again, this could be a variable that you set, so we don't have to come in here and retype this in. Okay, a little bit too choppy now.
Yeah, choppy.
So again, you play with it. So what we could do is go ahead and say, let's create a serialized field. We're going to make it a private float smooth. And we're going to set it equal to, I don't know, like 2. And
What's
then,
the F stand for?
Float.
Float.
It just knows that it's a floating variable instead of a integer, for example.
Gotcha.
And we can add smooth right here. So now we're just going to multiply smooth times this time.delta. How much time has actually passed between frames? And whatever this smooth is. But now what we can do, instead of coming back into here, we can just change the smooth here. A little bit better.
Yep, a little bit better.
So let's go ahead and set like a 0.8. Okay.
That looks better.
Looks better. I'm just not a fan of the ball itself.
It's just a
Yeah.
little bit of vibration there.
So yeah, again, that's something you can play with. I'd have to see how I had it in the other game. There's a few different ways to actually get the camera follow, but here we go. I'm gonna make that equal to 1 and just time.delta time. There we go. All right, coolio. Float means it has decimals exactly, right? So it does have some decimal points to it. Int is only whole numbers exactly. There are other forms of decimal numbers like doubles, but we're not going to get really into that. Float is our decimal numbers. Integers are our whole numbers. And we want to be able to have decimal numbers in here, so that's why we use float instead. Even though 2 is a whole number, we want the ability to have 1.5. So we want to be able to have that. All right. We have our camera movement. Next, let's try to move the ball. This is going to involve some input. We want to be able to click the mouse button. And when the mouse button clicks, we're going to change the direction from moving to the right to the left. And if we click again, we're going to move it to the right, and then to the left, and then to the right. So a single click is going to allow us to change direction. When does this happen? Well, this is the player we're talking about. This is player movement. So we're going to do this in our player script. And it already has the speed, which is kind of nice.
Did that auto-populate or what?
No, this is what we did last week.
Gotcha.
So we did the speed, and then we did, this is get the velocity component and set the velocity equal to moving to the right times the speed.
Okay.
We are going to go ahead and keep track of the direction in which we're going to do, and we could do this using something called a Boolean, private Boolean. Bool is just something that's either true or false. Okay. And what we're going to call this, we're going to call this X direction, X, D-I-R. And we're going to set this equal to true. And basically what we're saying is at the very beginning of the game, we are moving in the X direction. Okay. If this becomes false, we're no longer moving the X direction, which means we are moving in the Y direction. Did you order pizza for us, Mrs. Tubbsy? I mean...
You should throw a wrench in it and make it move to Z, too.
Well, that's what I meant. We're actually not moving in the Y direction. We're moving in the Z direction. Y would be up and down. We're not moving up and down. So we're moving to the right and then to the left.
Right, as Z is depth, right?
Yep. So this is positive X this way. This is positive Z this way. And then this is negative X. This is negative Z. And then positive Y. And then negative Y is going to go down. Yep. Also haven't heard the word velocity since junior year of science. Ooh. Okay. Chipotle.
Already ate it.
Already gone. All right. So what we can do now is say, well, cool. If we have in the update function, we can have an if statement. Look, it already tells us. It already knows. If we are moving in the X direction, no, we don't want to do that. So no sometimes. We're going to go ahead and do this block. So we added some curly braces. This says, when this is true, do these things.
Okay.
So if we're moving in the X direction, go ahead and move in the X direction. Otherwise, we want to move in the Z direction. That's exactly what else is. Else is...
When you tab, or when you enter down, it automatically creates the closing bracket?
Yeah.
Okay.
So, some of these, we call them IDs. The Visual Studio, which we're using right now, are smart enough to know that if you have an opening curly brace, you probably want a closing one as well.
Gotcha.
So the else is paired with this if, and you can actually click on it and see that they're paired together. So when this is false, we're going to do this stuff.
Gotcha.
Okay.
Makes sense.
And we're going to do teaching the fundamentals. Would XVEL be easier? Maybe I'm just kind of creating a flag that keeps track of the direction. Maybe at a later time, because speed is still speed, and we're going to move in whatever speed we're going to do. And as we maybe increase difficulty and speed gets higher, we're just going to move in the X and Z directions with this flag. If we ever implement like a jump, we'll do that in a different way as well. You sound like a teacher. Are you a teacher? No, not at all. I don't do this for a living.
No.
All right, so to move in the Z direction, it's going to look very similar to what we have up top. We're going to do our get component. We're going to do our rigid body, which contains the velocity. Okay. And instead of going to the right, we are going to say vector 3 dot
left.
Forward, actually.
What?
Because left is actually negative X. Forward is positive Z. Backwards is... Think of it as you are in a first-person shooter.
Yep.
And forward for you is always going to be positive Z. Backwards is negative Z. If you want to strafe to the left, that's negative X. If you want to strafe to the right, that's positive X. Jumping is Y. Crouching is negative. Or falling, I should say. Negative Y.
Okay.
That sounds so confused. What up, Damnation? But yes, we are going to complete that with speed. So, and you can actually go ahead and hover over these, and this shows that it's 1 in the X, 0 in the Y, 0 in the Z. And then here you can see 0 in the X, 0 in the Y, 1 in the Z, if you ever get confused. But all these are just unit vectors in those positions. Okay. Why don't you explain to me like I'm a 5-year-old? Yeah. We would do this using Roblox if you were a 5-year-old. Drunk, LOL. Yeah, maybe.
No, he is.
Oh, he is?
Mm-hmm.
Where is he at?
At home.
Just drinking?
Maybe.
All right, so cool. We have movement based on X direction, but now the X direction is always going to be true. Nothing is changing X direction. So at this point in time, we're still going to only move in the X direction. We don't want that. We wanted the ability to actually change X dir. I'm at home drinking 17 beers. Wow, that's quite a few. Yeah. We're going to go ahead and change X dir. X dir is going to just flip between true and false depending on the button press. Okay. And how do we get button press in Unity? Well, they have something built in for us. We're going to go ahead and leave a comment here that says change direction. Okay.
These are just notes, right?
Yeah, these are notes.
Okay.
Just for us.
They don't affect the code at all?
Exactly.
Gotcha.
So we can actually put down here like move the ball.
Got you. So like if you're quickly scrolling through your code and you're like, this is screwed up, I need to find where this code is, it's kind of easier to find it?
Exactly.
All right, cool.
So I'm going to try to change the direction first, and once the direction changes, then we're going to try to move the ball. So what we're going to do is say if, and to get the input, we're going to go ahead and say it's input. They have a few different things that we can do. We could actually make this the space bar if we wanted to. I'm going to make it the mouse button, though. So get input.get mouse button down.
I'm more of a space bar guy myself.
We could make it a space bar. And we included a 0 in between these parentheses. 0 just means the left button. 1 would be the right mouse button. And then all the other mouse buttons have different numbers to them. But
can you change the... Are they always going to be the same for every computer?
Yes.
Okay.
Yes. Unity just has this mapped to the 0th mouse button is the left mouse button.
Okay. Stupid. It's not a number.
It's just a mapping to the number. And I'm still about to finish 18. Damn, dude, share some, man.
Yeah, for real. Send some over.
So if we get a mouse button, we don't want to just set X direction to false, because once we change it to false once and we're moving in the Z direction, it'll always try to change it to false. And then now we're just going to always move in the Z direction. So we're not in program. Everything starts at 0 instead of 1 exactly.
Yeah.
So what we're not going to do is change it to false. We're going to change xdir equal to not xdir. So the exclamation point means not, or the opposite of. So if it was false, we're going to change it to true. If it was true, we're going to change it to false.
So flip-flops.
Flip-flop. So this says flip-flop your xdir.
Okay, so I see now, right? So change direction, right? So this is the command. So it's the button click. And then when that button clicks, this inside of the brackets is what's going to happen.
Exactly. Because remember, this update function runs 60 times a second. So we don't want all of these things to happen 60 times a second, so we need more control.
Right.
And these are actually called control structures. So we're saying, well, as you're running 60 times a second, do a check. Hey, did we detect a mouse button this frame? If we did, go ahead and change the direction. Cool. And then this just says, okay, based on your X direction, what's our velocity going to be? Is it in the X direction or the Z direction?
Cool.
Okay. You could do things if not alive as well. Yeah. I typically go game over, and not game over is my flag for that. But I do have usually like an is alive flag as well. So like if I'm doing a RPG or like a 2D platformer, maybe there's a detector on a cliff as you fall off the cliff, and you hit what's traditionally like in Mario when you what do we call those when you in a 2D side scroller where you fall off the map. We used to call them suck downs back in the day, but they never physically actually.
I never called them anything.
But usually there's a little trigger down there that says, hey, the player has entered this area, go ahead and unalive him. And that's where we would hit that trigger.
Gotcha.
Also, back to the pizza topic, you guys literally have pizza 2 doors down. I don't think they're open yet. They don't open until the afternoon, I think.
It might be open right now.
They might be open
12.
right now. Suck downs. Damn you, Josh. Dude, we were kids. We didn't think anything like that. But like, I just remember as like, maybe it was because if you remember the original Super Mario Brothers and the underwater levels, for whatever reason, when you went above those chasms, they did pull you down. And maybe that's where we kind of understood that from. But in general, those things don't physically pull you down. So
just pepperoni? Ew.
Jeez, Tubbsy. Miss Tubbsy. All right, let's see if we actually did that correctly here. So here we go. I click, and the direction Ellie moves in the camera likes to follow as well. And you can see we can actually, right now it's hard to get the perspective, but you can actually see the ball position move in the camera at a lerped rate, linear interpolated rate. So that's kind of nice. Pineapple, you are I like pineapple.
Pineapple on pizza's bomb, Josh.
Yeah, ham and pineapple.
It's a California thing.
Pineapple and olive? No.
Oh, God.
That's Deadpool.
That's gross.
Sweet and salty. So we have our basic movements now. So that's not bad for today. We would eventually start making some spawned platforms that come out to the left and to the right here. We need the ability to detect if the ball has fallen off the platform. And I'll show you why we can't just turn the gravity on. This works for a big platform like this. But if we turn the gravity on, then it's going to run into the littler platforms, and the little platforms are just going to kind of like explode and fall and do weird things.
Implode?
Not quite. Not enough pressure for that. It's not a California thing. It does belong on pizza, okay? It's delicious. It really is. So next time we are going to do that. We're going to get our nice little platforms. We're going to randomize their directionality. And we're going to make sure that the ball can detect when it's on top of a platform. Basically, think of it as a little eyeball at the bottom of the ball that kind of sees, hey, is there anything underneath me? And if not, it's just going to be like, no, and it's going to fall.
Dig it.
Also, I don't know what I'm watching right now on the stream. I'm happy to just be... Oh, that's fair. Well, thank you. Thank you for just being here. I don't know if there's anybody, maybe Josh, that does this for a living, but anybody that had any particular questions or anything they wanted to see. I know there was a lot going on there. We did our camera follow script, which had some interesting things in it, a little bit more computer science-y. And again, a lot of it's like, well, how do you remember this stuff? Well, it's literally, well, this is player. Let's go back to camera follow. Literally, this is just experience. I've taught this particular game design like 4 or 5 times now. And when it comes to the C# stuff, literally these are things that you would use all the time. Your vectors, your transforms. So that's stuff you just get used to if you're in the Unity game design realm. Again, there's tons of good resources and tutorials for all these things at a beginner's level, hopefully including this one. If I can answer any questions about what any of this means, I'm more than happy to. I don't know game dev, so I'm actually learning too. What was something you did learn, Josh, and something that maybe you might have had a question on that didn't quite make sense? Or even Tubbsy, if you had anything that you wanted to get clarified. What's nice is the quote math that we're doing is done for us. Literally, the amount of math that goes on in this function is way beyond like standard people understanding. So just go ahead and let the vector, like the function, do it. You know?
Yeah, I think that's probably the biggest thing. I think that's what I've heard you say a lot of times with Unity is it's very simple.
Yeah.
Like in terms of coding, and I think that like someone like me, just sitting here, we didn't do any math, no math whatsoever. And it's not that I hate math; it's that I haven't done math in quite some time.
Yeah.
Especially advanced math that goes into like game design.
It actually tells you the formula. That's actually funny.
Yeah, that's what I was saying. It tells you the formula down there.
Yeah.
But like, I thought video game design had so much more math involved that looking at this right now and knowing like, because you've done this whole thing before. Yeah. You showed me the end result in the game that you created, right? With what we're making right now. And to my understanding, there's just not much math that gets involved, which is great because that makes it accessible to so many more people.
Yeah. What I tell people in general is if you do your standard operations, add, subtract, multiply, divide, if you kind of know when and where to use those, things actually start to kind of make sense. So for example, how did we find the distance between the two positions? If you have some inclination about some vectors, and this is literally just an X and Y and Z position, you know that finding the distance and directionality of 2 points is really easy in vectors. It's literally the subtraction of the two. You subtract the X's, subtract the Y's, subtract the Z's. And that is the best way to do it. Same thing with adding an offset, right? You have a starting point. If you add an offset, it gives you a new point. And all it does is add the X's, add the Y's, and add the Z's. So because of that, it makes this math a lot easier. If you guys remember your old school distance formula, which I hope to God you guys don't remember. I just teach math, so I remember that off the top of your head. There's like square roots and squares involved. And it's like, no, we don't need any of that. We have vectors that kind of help us out with all that nonsense. And then again, when we do this, it kind of shows us the formula down there at the bottom, A plus B minus A times times time. If we needed it, but really once you kind of know what lerp does, you have a starting point, you have an ending point, and you have a smoothness factor. That's all you really need to know. And then it calculates what would be the best position for it, and then we set it equal to the transform, so the position. People think programming is like calculus. It's more like pre-algebra. Yeah, I'd say maybe some more algebra. Unity could present itself with some trig, depending on what you're doing. It really doesn't need to be. There's ways to get around it, but if you wanted to say have a javelin that you threw, and I actually had to calculate this, but like your character throws a javelin and you need to calculate its trajectory, then maybe you have like a tangent involved, but it doesn't need to get that out of hand. It really doesn't. There's probably better ways to do it. Player. player we start introducing our ifs, so our conditionals. Conditionals are big in programming because we don't want to just do something every single time. So we need to introduce cases in which we actually do these things. So if is going to be our big one. If something is true, literally this is a function that returns true if it's detected a mouse button down. Cool. This is literally a Boolean variable, which is something that's true or false. And we called this, and we can actually put a comment up here. This is flag that keeps track of ball direction. And that's all that is. If it's true, it's moving in the X direction. If it's false, it's not. And that's something that we define. So since we defined it, we can keep track of it that way. It's my way. Sorry.
My way in the
We got some good bangers going on in the facility right now. For sure. If that is what we got today, and those are the questions, I'm going to go ahead and let Tracy decompress before he starts to stream here in maybe an hour.
Yep.
Opening number 19. Jeez, damnation. Slow down, my boy.
Attaboy.
We're going to go ahead and, God, this is only 36 minutes, so this is relatively quick.
Mm-hmm.
I knew this was going to be a little code dense, so I didn't want to do too much today. But we made some good, his mind's probably hurting. We made some good progress. All right, we're moving the ball, we're moving the camera. So you can kind of see how, with the steps we've done today, there's very few things that we got to add to actually make a functioning game. We can make our platforms, game over detection, and maybe our little diamonds next time. And then maybe the last time we work on the HUD and some saving. So absolutely not. I've not anything else. And you got food. You got some hopefully delivered, I'm guessing. But yeah, we're gonna go ahead and do a sign off here. Thank you guys for coming on. No, we didn't change it on this one either, but that's fine.
That's fine.
I
am not Darvis. I am Tubbsy.
Chinese food from DoorDash. Very good. Yeah, I've been Sideconius. This has been Tubbsy, and this has been ZigZag, I guess.
Yeah,
so,
we call it ZigZag.
ZigZag. So get ready for round 3 next week, guys. Take care. All right. Only about